In this video, we will solve 3 permutation problems. This right here will be the first problem, and this right here will be problem number 2 and problem number 3. So let's get started with the first problem. So we have a race of 3 people, and each person will get an award. Someone will get an award for first place, second place, and third place. And we want to know how many different ways can awards be given. So in this problem, order matters. And so we'll actually do this one completely. We'll actually go through each scenario. So we have player 1, player 2, and player 3. So there's a first place award, a second place award, and a third place award. So we can say that player 1 gets first place. Then player 2 could get second place. And we can say that player 3 will get third place. This is one scenario that works. We could also say player 1 will get first place, but player 2 will get third place. And so player 3 therefore would get second place. And so what we did here was we said player 1 got first, and that caused player 2 and player 3 to either get second or third. So player 1 had 3 options. He could get first, second, or third, and we said he got first. That affected player 2 and player 3 outcomes. They could only get second or third. So in this problem, order matters. And so we could do something very similar for, we could say that player 1 could get second place, and that would cause player 2 to either get first place, or player 3 could get first place, and then likewise we could have second in between. And so we could do the same thing, saying player 1 could get third place. Each time we would get 2 possible options. So 2 here, and if we wanted to, we could say player 1 could get third, and we would get 2. And so there are 6 order. And another way to think about this is that we have 3 people, 3 awards, so 3 factorial, which is 3 times 2 times 1, which is 6. So this way we went over each scenario, but if we didn't have, if say for example we had 10 people and 10 awards, it would be 10 factorial, which would be way too hard to illustrate. And so now we will do the second problem is going to be a little bit different. So we have 5 text messages, and we want to reply to only 3 of them. We will only reply to 3 out of the 5, and we want to know how many orders, what are the possibilities. So in this problem, the way we're going to write it is going to be a formula. So we say NPR. N is the number of objects, so 5 text messages are the number of objects. R is the number that we reply to, the rate, if you will. And so is equal to n factorial divided by n minus r factorial. And this formula right here only applies to permutation, not combination. With permutation, order matters. And so we simply plug in what we have. So we have 5 text messages, so 5 is n, p remains the same, p for permutation, and r, the number that we will reply to, 3, so is equal to. So we said n is 5, so 5 factorial divided by 5 minus r, r is 3 factorial. And so what we would get here is, we could say 5 factorial as 5 times 4 times 3 times 2 factorial, or 2 times 1. But I'm keeping it as 2 factorial because 5 minus 3 is 2 factorial. So they would cancel out. Cancel. And so we get 5 times 4 is 20. 20 times 3 is 60. So we have 60 orders, 60 possible combination. So the answer for the first one is 60. And now we'll do the second problem, where we reply to all 5 of them. This problem is like the first problem. Let me just look back at it. So we have 3 people, 3 awards. Essentially, if we wanted to use a permutation formula, we would have 3p3. Now, this is equivalent to 3 factorial, and I'll show you why. And so, we have 5 of them we're going to reply to. So, let me just set it up. So, we have 5 objects, 5 text messages, p, and r is 5, because we're replying to all 5, is equal to. We plug it into this formula. So, n is 5, 5 factorial divided by 5, n is 5 minus 5 factorial. And so what we would get here is 5 factorial divided by 5 minus 5 is 0. 0 factorial. 0 factorial is 1, so we get 5 factorial divided by 1, which is simply 5 factorial. And so that's why for the last problem we could simply say 3 factorial. We didn't need to deal with like 5 minus 3 because 3 minus 3 was 0, and we would simply get 3 factorial. And so just to solve this problem, we get 5 times 4 times 3 times 2 times 1, which is 120 possible combinations or orders. And that's all we need to do for this problem.